This is an audio production quick take by Marwak. The content that follows is from the eBook VoiceOver on Linux, which explains how to create professional voiceover products using Linux and associated open source software. Today's topic is FFmpeg Audio Basics. We'll go over essential commands and syntax in using FFmpeg to best effect in your audio projects. FFmpeg is a powerful utility for processing audio and video, combining sources, separating and extracting components, and converting different encoding formats. For processing audio, there are a few FFmpeg option switches that you might find yourself returning to frequently. These options are the sample rate, set with the command alias -AR, the number of channels, set with the command alias -AC, and when encoding MP3 files, the bit rate, set with the command alias AB. Each of these is followed by an integer value, without commas if it is in the thousands. You can also specify the bit depth in an FFmpeg command with the -sample_FMT option switch. FFmpeg is very handy in converting from one encoding format to another. For example, when you're done editing your audio and normalized its PCM values, you can use FFmpeg to re-encode and export that file to an MP3 file. As in the example shown here, you can extract the audio component from an MKV video container file by simply specifying WAV as the output format. Although there are more elegant ways to tell FFmpeg to extract audio from a video file, this is much easier to remember and just as effective, while also leaving your source video file unchanged. Let's walk through the syntax. The option switch -I is key to telling FFmpeg the file it is to operate from. Most voiceover work is done in mono, and you can have FFmpeg mix down the audio ahead of time, or split the mono file into stereo channels at this stage to not have to do that in later processing. The $2> dev null line is an optional quick shorthand set of code to keep your screen from filling with more information than you'll be using. More on standard error redirection in a moment or two. FFmpeg has robust filtering capability. Here's an essential filter that we'll use next to measure the RMS level of an audio file. Remember -AF as the option switch that filters audio. A good way to remember it is to think of AF as an abbreviation for audio filter. The audio filter used for measuring both RMS and peak volume levels is the volume detect filter. Here's the file we'll be measuring. FFmpeg is a complete cross-platform solution to record, convert, and stream audio and video. FFmpeg is useful for measuring the RMS and peak volume levels of a PCM audio file. Here's an example command to get the volume measurements and then filter down to only the values that we're interested in. Let's parse through the components of this command. FFmpeg takes the input file test.wav and runs it through the audio filter volume detect. As FFmpeg does video too, and we're not doing video with a WAV file, the -F option switch tells FFmpeg to use a null video format, and then discard the null video output to dev null. As FFmpeg sends its information output to standard air, to use standard out for its processing output, we need to redirect standard air, descriptor 2, to standard out, descriptor 1, with the shorthand syntax of $2> $1. This is necessary so we can use grep against the information that is now in standard out, as grep doesn't parse standard air. Grep returns the whole line that contains the search term dB, so we'll then use the awk command to further parse the lines returned by grep with the $F field separator in awk to show only what we're interested in, which in this case is the information in fields 4 and 5, as separated by spaces in the grep output lines. Now let's run our command. The result returns the mean volume, think root mean square in RMS, and the max volume, which is the peak volume. That's what we're interested in, but we had to do some filtering to clear out a lot of other clutter to get to just that. Let's take a look at what we filtered out, and why the different parts of the command are useful for a clear reading. We'll go back to just the FFmpeg part of the command before it's piped into grep. There's a lot of general information output that FFmpeg throws through standard air. In particular, it shows that the file is pulse code modulation, is at a 44.1 kHz sample rate, is audio in one channel, and the samples are 16-bit depth. And here's the information we're looking for in the first place, the RMS level and the peak volume level. Now let's grep out only the lines we're interested in by filtering out all lines but those with dB in them. And sure enough, we get only the lines we want, that is, those with the actual volume levels. Now let's awk out the leading text ahead of the level measurements, that is, the parsed volume detect and the hex value, so that we get exactly what we're looking for without any clutter. We'll use the -F option switch to define the field separator we want awk to use. In this case, it's a space, because we have a space after volume detect _0, and a space after the @ sign, and a space after the hex value. We'll then print the fourth and fifth fields, which happen to be the mean volume and the max volume that were included in the grep filtered line. And that's a significant improvement, considering the extraneous information that we started with. This has been an audio production quick take by Marwalk. For more details on using open source tools for audio processing, see the ebook Voice Over on Linux by Mark Caldwell Walker.